And let me introduce our next speaker, myself. I'm going to be talking about 3D on the web and introducing a library that makes it a bit more accessible. To write 3D code on the web, I need 1 second to actually reload my Prezi video because I have my presentation there. So let's see if this crashes. Magic, it didn't. Okay, and let me. Okay, I'm starting now, so I'm also spotlighting. Cool. Hi everyone, my name is Alex, and I'm going to be talking about the beautiful love child of Three.js and React, which gave us React 3 Fiber, which is a very approachable library for writing fairly efficient code for the web. That's 3D. Before we get into that, let me give you just a very short summary of what happened in the 3D web in the past decade. So prior to 2011, we didn't really have a lot of choice to actually use effective 3D rendering on the web. Our best bets were plugins, Java applets, or Flash, and that was a choice of Prezi as well for some time. But that wasn't really a great idea, and that was plugin based, and that was not super performant. In 2011, we got 2 very important features shipped into HTML5. This was coming through the Canvas API. We got the 2D rendering context and the WebGL context in the same year. Browsers started to adopt these standards. And with that, we got GPU-based 3D rendering for web browsers without any plugins. However, the API for WebGL for accessing the 3D capabilities of your browser were really hard to use. So in the coming years, a few libraries were spawned into trying to humanize writing code for the web, or 3D code for the web. Some of the prominent names include Three.js and Babylon.js. And another library that was created in 2019 was a reaction to React's overtaking of the web around this time. So what the authors tried to do with this is try to somehow host Three.js's very efficient and useful 3D capabilities into a React-like environment that many people are used to working with. And the future of 3D on the web I think is very interesting. We are going towards more and more immersive experiences that are actually based on this breaking point in 2011. All right, so let's jump into this thing. I will be showing a slight comparison, but these are not really comparable. These are tools for the purpose. So you have to pick which one do you want to use. Do you want to go with Three.js or do you want to go with React 3 Fiber? Both of them have their better uses. So let's try to compare and figure out when can you, or when should you be using either of them. So Three.js, as I said, is the wrapping layer around WebGL for your browser. It is an imperative style of code writing. You create your objects, you add them to a virtual scene, and then you create a snapshot of that into your canvas. Since you get access to all the low-level details, you get a better control over your code. It's a bit more efficient in the long run, but that's not really a question with like very small 3D applications. And this is where React 3 Fiber comes into place, because you now get to use a React-like declarative style of coding with more defaults and less details exposed to you, which kind of makes it a bit more enjoyable and approachable to write 3D code. I prepared a bit of demo. Let's hope that my computer doesn't shit itself. I created 2 examples of the same application, or the same 4 scenes. So in the first one, what you're seeing right now is just a cube that's interactive, and I can rotate it. The second scene is a cube that rotates by itself. A third scene is a bunch of cubes that have different colors, different spins and sizes. And the third scene is Spider-Man with some hover action. So if I hover, it reacts to my hovering. And this first application was made with vanilla Three.js. So I'm not using React 3.js in this case. And I recreated the same scenes with React 3. This is the single cube. This is the rotating cube. This is a bunch of cubes. And this is Spooderman. And this guy does a bit more now. So like, if I manage to catch it, I actually can add HTML links into this canvas and follow those links. So I will be showing how these scenes were made if my computer resets. Okay, cool. So the first scene was the hello world, the basic box. This is the imperative style. This is the vanilla 3JS code that I'm showing you right now. As I mentioned, you create everything yourself. You create your scene, you create a camera, you create a renderer, you create a light added to the virtual scene, you create a geometry containing some material, and you put it into a cube or a mesh, and then you add it to the scene. And then you have to create a so-called render loop yourself, in which you basically self-recurse in a delayed fashion. You call this function with the request animation frame with about 60 frames per second. And in this function, in this render loop, you get to do whatever you want. We generally do some animations, like animate our scenes forward in time and take snapshots of our scene into the canvas with the renderer. It's very imperative, very hands-on, low level. In contrast, what you get to do with React3.js is once you get access to this canvas component, that is basically your scene. And inside of that, you declaratively, in this very clean hierarchic fashion, you declare you want this interactive control stuff that I can rotate whatever I see in the scene. I want one point light in it. I want a mesh that is consisting of a box geometry and some material. This is very nice and clean and React-like, very familiar to most of us. In the second case, with animations, you create the scene the same way, like you would, but in the render loop that I mentioned, now you do some changes to the state of that cube that you added. So in every point in time, I will change the rotation of that cube. And that, if you render it continuously, will give the rotating cube effect or the animation. This animation with the React case is through the use frame hook that you can actually only use within Canvas. This use frame React hook, once you give it a callback function, that function is going to be executed 60 frames per second or 60 times per second. So once you have a reference to an object of yours, you can animate it the way you want. You can change its rotation, you can change its size, color, whatever you feel like. All right, it gets a bit more interesting at a few more objects. So in the vanilla 3JS case, if you want to handle a multitude of objects, let's say we generate a bunch of box properties with different colors and spin speeds and sizes and so on. The way to add all of these cubes into the scene is that you have to iterate over it, create the cubes yourself, and then add individually all of them to the scene. And once you get to the animation part, you have to iterate over all of those cubes and you have to call some sort of function on them to animate. Let's say we animate all of their properties so that it becomes very vivid and very live. So this style of writing code, you can see it's a bit more hands-on again. This invites object-oriented fashion of writing code. So you would build your abstractions and you would create scenes, and in that everything is animatable. And then you can animate everything with like a generic interface. In a React-like code, you would create your abstractions like you would create abstractions in your React DOM tree. So let's suppose that we create a concept of an animated box. This component, this React component, takes care of the duty of rotating itself. So it gets a reference to the cube. It creates this animation loop with a use frame that we showed before, and then you just return that box. And once you generate your box properties with the colors and the spins, you basically just map over that to get the result of all the animated boxes in the scene. Very React-like, very clean. Importing models is a very common thing to do because those look super nice, like that Spider-Man model did. In a vanilla case, you get access to loaders, and then you can use these loaders to load something, and in the callback function, you can add it to the scene. Fairly easy. In the React case, you have to use this tool gltf.jsx. That's a CLI tool that generates a JSX file from your models, and you can import it so simply and add it to your scene like this, and your model will appear. And it gets a bit more difficult, actually, if you start doing interactive stuff with models or anything interactive really on your scene, because you have to maintain your mouse position. You have to create on mouse event handlers on your canvas, maintain where the mouse is, calculate what that means in the virtual world, create raycasters, virtually tracking your pointer's position into the virtual world, and create your interactivity or changes in the scene based on these things, creating your own API, basically, of accessing stuff in the virtual world. But the React case is very nice to you because it's exposing down in here, you can see it's exposing very nice API to just get a function callback as soon as someone moves the pointer over your model. You can see I didn't create these APIs, these were generated, and these are default with most of the components that you get with the library. And I think it's fairly clean to use. You can use state objects like you would do in React, and you can do conditional rendering as well like you would do in React. This was the thing that I wanted to show you. I invite everyone to try out React 3 Fiber. It's very approachable again. I think these are very good resources to get started, get you interested in 3D on the web in general. The first three links, the very bottom link is the demo that I showed you just now. And the one above it is a workshop material that I prepared that's about 2-3 hours to code through, but it will get you a bit more hands-on with importing stuff and creating a very immersive 3D data visualization project. Thank you. And I am back in Zoom and waiting for questions. Thank you, Alex. Nice talk. I see Navid has a question.
Hi. Great talk. I heard you mention that things are getting called 60 times a second. I wonder how much is that a lie? And is it really 60 frames per second? Because I've never seen like a JavaScript 3D thing render very smoothly.
Oh.
And
have you used Prezi?
Are we using JavaScript? I mean, we are, but okay. Smoothly is also very stretched there, but
okay. So this API on your browser, request animation frame, what this one does is it will try to schedule it no more than 60 frames per second. So if you're doing something that, if you're doing something that can be completed in less than 16 milliseconds, then it will be 60 frames per second. If you're doing something that's, if you calculate something very complicated, convoluted, of course, you're not going to hit the 60 mark. But by default, this will work. And I think most of the animations that I've shown you would be 60 frames per second.
Okay. Thanks.
Yeah, I'm sure actually Andras probably has a lot more insight on this than I do. I'm a very naive Web 3D enthusiast, but he's probably closer to home in this territory. Right, if no more questions, then I'm going to close it here. I will share this presentation as if you want to try out. I really encourage everyone to try out these demos or the workshop because it's, to me, it was really revealing that it's pretty cool and easy to use. Mate and Mishi?
Who was first? You told my name first, so
Yeah, Mate, do
it. I was just interested in the Spider-Man's model format. What is the current standard in that? Because I stuck like 10 years ago with OB files. I guess things evolved from that.
So this was from a format called GLTF, which is GL transform format. I guess graphics language transform format or transfer format. So this format is a JSON file that's actually pointing to a binary description. Probably it's an object file somewhere hiding in the background, but there is a JSON file describing what's inside of the scene and some properties of that thing. If you go to the website, what's the free one that hosts a bunch of models? sketchfab.com. You can download everything, I think, in this GLTF format, and I've seen that most of the tools are supporting this format. Thank you, Michi.
I'm just started thinking about that, checking your demos and the 3D on web. That what do you see about this? You started your presentation with this. The 3D on web is just getting into shape or getting a thing. What do you mean about this? Like, will we see many, I don't know, UIs built on web that has 3D, or games on web, or what's the future you envision here? I'm really curious.
Sorry, didn't remove my spotlight. Yes, so games on the web, it's already a thing. I think it's already been a thing for a while. One of the tech demos for demoing, what's the tool again that Engine was using? Emscripten was a shooting game that was made, again, highly performant, showcasing Web 3D and Emscripten. And you can already do like very interactive game experiences on the web. What I'm envisioning here is more 3D seeping into our currently flat web experiences. And I think if you're browsing through some of the examples that are in the presentation, I'll probably share the links, you'll see what's possible with it. So you will find an artistic web page where you scroll through. It's not only just a parallax background, but things floating in, things rotating. You get configurators with this stuff. So basically you can order from IKEA, where you can actually in a 3D environment configure your colors, your objects. A lot of immersive stuff is hitting the market, I think, in the past 2-3 years already. But I think this is going to continue with it. And again, I think this React library is going to help with that, because you have a lot of React developers now, and you have easy access to 3D now.
I hope it won't be the metaverse.
That's also happening. Web AR and Web VR is also taking a big chunk.
Thank you.
Cool. Thanks for the questions, and thanks everyone for joining for the talk, and especially thanks for all the presenters. I know it's been a lot of work to prepare the presentations, but I hope that you have enjoyed it at least half as much as I did, because for me it was super great. So again, let's give it up for all the speakers and all the guests holding on until 6 p.m. or 7 p.m. in Riga, Latvia.